Now let's take a look at the atypical antipsychotics, the second generation drugs that have been developed. These target the D2 receptors less, or they vacate it more quickly. Basically, same idea. They are going to block those D2 receptors to a lesser degree. And as a result, they seem to produce less tardive dyskinesia and these Parkinson's-like symptoms just because there are more D2 receptors, it seems, in the basal ganglia system that's involved in movement, as opposed to other parts of the brain, like the frontal lobe, where we're seeing some of the effects of these drugs as well. So targeting the D2 receptor less is associated with less certainty that the person will develop tardive dyskinesia or Parkinson's-like symptoms. They still can, but not quite as likely. They also are beneficial because often these typical antipsychotics can help people with negative symptoms that were not typically helped with the typical antipsychotics. So typical antipsychotics generally did not help people with negative symptoms. The atypical antipsychotics do. So we can associate then dopamine, D2 receptors with antipsychotics, but we're going to see it's much more complicated. And this is true for the great majority of drugs used to treat different psychological disorders. We often talk about them as if they affect only one neurotransmitter system, but they affect many neurotransmitter systems. So here we're looking at a Wikipedia page looking at the atypical antipsychotics, and we're seeing the binding profile. So these are the generic names of a variety of different atypical antipsychotic drugs, and we're looking here at how well they bind to these different receptors. The greater the number of pluses, the more it binds to that receptor. And so let's take a look here. First, we have D1, D2, D3, D4. Those are 4 different subtypes of dopamine receptors. And when we just take a glancing look, we can certainly see that all these atypical antipsychotics are definitely binding to the D2 receptors. They just do it a little bit less than the typical antipsychotics. In addition, we're seeing that most of them affect D1 receptors, and they all seem to affect the D3 receptors, most affect the D4 receptor. And so the difference in tardive dyskinesia and so on is that there are just a greater concentration of D2 receptors in the movement system in the basal ganglia than in some of the other parts of the brain. But the effects of these drugs doesn't stop with dopamine, does it? So we're going to see here, what are these guys? 5-HT, that is serotonin. And so we're seeing a variety of effects on 5-HT1A, 1B, 2A, 2C, 6, and 7 receptors. So these are all serotonin receptors. And again, wherever there are pluses, we're seeing amounts of binding to them in the antipsychotics, in these atypical antipsychotics. And again, where there's 4 pluses, that's a high level of binding. And we're going to see that that's important in a moment. In addition, we're seeing binding to these adrenergic receptors, shown here with the little alpha symbol, alpha 1, alpha 2. So that's the adrenergic system. The M's, M1 and M3, those are the muscarinic receptors. And that might ring a bell, muscarinic. That is a receptor for the acetylcholine system. The H we have not talked about yet, I don't think, or maybe not much, but the H is histamine, and we see that a lot of these drugs also affect the histamine neurotransmitter. And so we're seeing just, that we talk about antipsychotic drugs as being dopamine antagonists, but they are also affecting serotonin, the adrenergic system, acetylcholine system, and the histamine system. It's thought that atypical antipsychotics may help resistant cases, so drug-resistant cases, individuals who do not respond to the typical antipsychotics, because they act on the serotonin synapses. So those actions on serotonin are thought to be pretty significant. There's also a glutamate theory of schizophrenia. The basic theory is that there is too little glutamate. And the evidence in favor of this is that the drug PCP, which mimics schizophrenia by inhibiting NMDA receptors, so if you inhibit NMDA receptors, you seem to be able to trigger schizophrenia-like symptoms in individuals. In addition, the neurotransmitter glycine, which I know we haven't talked about much, but this neurotransmitter glycine acts on NMDA receptors, and increasing glutamate amounts through administration of glycine also decreases the positive and negative symptoms of schizophrenia. And so one way of thinking about it is, so I'm drawing what hopefully looks like a piece of playground equipment you may have played on as a child, a teeter-totter. And so these things, these two seats over here are balanced, and we think of dopamine as being too high in the case of schizophrenia, and now we're adding that, oh, glutamate might be too low. Now, how can these two both be true at the same time? Well, it turns out that in many synapses, dopamine and glutamate are going to influence each other. So if dopamine levels rise, glutamate levels are going to go down. And likewise, if glutamate levels rise, then dopamine will go down. So when an individual takes an antipsychotic drug that lowers dopamine levels, it will also end up increasing glutamate levels. And so we can see that, that's how we get the glutamate theory, that there's too little glutamate in the case of schizophrenia. And so now we have two theories, right? Our dopamine theory is that dopamine levels are too high, and now we have the glutamate theory that glutamate levels are too low. There is a bunch of research being done right now looking at glutamate and finding new treatments using glutamate.